Okay, everyone. So today we're going to talk about finding the circumference of a circle. The circumference of a circle is the distance around the circle. And it's kind of like the perimeter is for squares and rectangles. The circumference is for a circle. But first, we need to go ahead and we need to talk about a few things. First of all, we'll call this key concepts. First of all, we're going to go ahead and remember that pi, which is technically spelled pi, okay, I believe that's Greek, and pi, the symbol for pi is this. This is a symbol for pi, very roughly. It's not perfect, but something like that. And it basically equals, pi equals 3.141592. Keeps on going forever, never stops to infinity. And it's an irrational number, which means that it does not have a repeating pattern, and um, it just keeps on going forever without having a foreseeable repeating pattern of any kind. And we're going to go ahead and we're going to round pi, okay? So this is the other key concept we want to talk about. We're going to take pi, we're going to round it to approximately what most mathematicians round it to, 3.14. Because it's a much more manageable number, 3.14, than the irrational number that it actually is. Here's some other things that we're gonna go ahead and we're gonna assume these things. And so it's gonna be the second piece, which is given. We're gonna have a few givens here, and givens are things that we assume in geometry. Okay, so the first given is we're gonna assume that circumference is equal to the variable c. Okay, so it's the variable c. We're going to make another assumption that diameter is equal to the variable d, lowercase d. And remember, diameter is, and let's go ahead and have our friend Alfred help us. Alfred, do you mind lending us a circle? Thank you. And we're going to get this circle here. Thanks, Alfred, I appreciate that. I'm gonna make them a little bit bigger. And recall that the diameter, if there's a center point, the center point being, let's say, here in the center somewhere, the diameter is the distance from an edge of the circle passing through the center point to the other side. That whole distance, that's our diameter. And that's what we're going to say is d for simplicity's sake. And we're going to assume that the radius of a circle is going to be r. We're going to make r the radius. Remember, the radius is from an edge to the center point. That's the radius. We're making that r. Okay. And remember the circumference, just to review, the circumference is all around the circle, the distance. It's all around the circle. That's the circumference. Okay, and that's exactly what we're going to be solving for, that actual distance. Okay, so I want to make sure that we have everything we need. There is one more thing that I'd like to say about radius. Radius is, let's make this a little bit smaller. The radius of a circle is equal to half of the diameter. It's See if you understand why this is. Okay? The reason for it, in case it's not super obvious, is because if you get two of these radii, you make one diameter. Okay, so the radius is actually half of the whole diameter of the circle. And the last thing I'm going to go ahead and point out is I might use from time to time the symbol for circle, circle symbol, which is a little bit like a circle with a dot in the center, like a center point. Okay, and I might need to use that from time to time. All right, so I think we're pretty set up to get into our problem solving. And we're going to go ahead and we're going to learn about what the formula for the circumference of a circle is. All right, so we're back, and so we're going to go ahead and talk about the formula for the circumference of a circle here. I'm going to switch colors. I think I'll keep this color. It's a nice color. And I'll make this part 2, and I'll call it the formula. Let's keep it real simple. Formula for circumference of circle. Let's use a symbol. Yeah, it's much faster. Okay, so let's do it. Here's the formula. I'm going to give it to you straight. Circumference, remember we're using C for circumference, is equal to 2 times pi times r, or radius. Remember, r is the radius, if you recall. And remember that we are making circumference equals 2 times pi. We're making pi 3.14. We're estimating it because it's easier to work with. Okay, times whatever r is. And I want to go ahead and state something interesting. You can say that another version of the circumference formula, you can say its circumference is equal to 2, or not 2. It's actually equal to, another version is pi times d, and d is the diameter. Now, why do you think that is? Pause the video and think about it for just a minute. Okay, so if you pause the video and you thought about it, here's why this formula works along with the first formula. Because the first formula, which is 2, has a 2 times an r. What happens if you multiply 2 times r? What happens if you have 2 radius, or 2 radii? Well, it becomes a diameter, because remember, 2 times the radius, the radius is half of a diameter, so if you multiply it times 2, it becomes the diameter again. And then the pi is here. Let me use orange. The pi here is the same as the pi here. So in essence, both these formulas are actually equal to each other. You're just written differently. So which one do you use? Whichever one you like. I personally like this one. It's more writing, but I just like it more, and I memorized it that way. Okay, so back to what we were saying before. This is what we have so far. We have 2 times 3.14 times r. And now all we really need is to have a problem. I will state one more thing. There's another way of writing these formulas. You will also see it 2 times pi, which is 3.14 estimated, times r. And the way you're going to see it in high school and college is people are going to go ahead and take a shortcut. They're going to say C equals 2 pi r. Because you assume that there's a multiplication in between these variables and numbers. Okay? So if you state it like that, that's pretty short and sweet and efficient, and we like that in math. Or you can say, also equally efficient, even more efficient, pi times d, or pi d. So if we want to really get to the most efficient way of writing these formulas, this is how we write them in the upper levels. Okay, all right. So now we're ready to solve some problems, if I do say so myself. And I think that we're going to use the same page to solve a problem. So go ahead and pause if you need more time writing this information down. This whole explanation, by the way, was to get to this point where we are now, where we're saying that the formulas to use are this one, circumference equals 2 pi r, or circumference equals pi d. All right, so let's get to it. So pretend that we're solving for the circumference of the following. Let's write everything down. So part 3, let's say the directions are to solve for the following. And let's say that we are using this symbol here, this planet. Okay, looks great. Looks like maybe like a Neptune. And let's say that Neptune here, let's go all the way down here. Let's say that it has a diameter. Let's say that this is a center point. The diameter is actually d equals 2, I was going to say 2 meters, but it's actually more than that. Just for the sake of argument, let's just say it's 2 meters, even though it's a planet. Okay, and so we're going to say, okay, let's solve this. And of course, this is example number 1. So we're going to say c is equal to 2 times pi times r. So we're using the most efficient, one of the most efficient versions of the formula right from the get-go. So that means that c is equal to 2, okay, times pi, which is 3.14, approximately, times r. So what's r here? In this scenario, if the diameter is 2 meters, then r has to equal, in this scenario, 1 meter, because it's half of 2. So it's 1 meter. Okay, let's go ahead and multiply 2 times 3.14. That's going to be 6.28 times 1 meter. Circumference is equal to 6.28, because anything times 1 is itself meters. Okay, great. So you have your first problem, example 1, and we have it solved right there. Now remember, it's really important that you keep on reinforcing for your understanding that the radius is equal to half of diameter. This is a big point in working with circles. Okay? All right, so I think we're ready for our next example. And just make sure that Alfred doesn't have anything more hidden things for us. Oh, you do. Thank you, Alfred. Let's use that. So let's keep that there actually. And let's take the whole screen and set up an example 2. Okay, and while we're at it, let's have a little bit of music. Okay, what's next? So pretend we have this planet. Let's see if we can choose it somehow. Okay, great. Make it nice and big. And we're going to say that this planet has a radius. And the radius of this planet, okay, is where? Let's think. Let's use blue. Here's the center point. and here's the radius, right up to here. And I'm going to say that the radius is equal to 2 feet. Ha! It's so funny, but let's just pretend. Radius is equal to 2 feet, just for fun. It's much, much larger than that, of course. Radius is equal to 2 feet. And so let's use the formula. C equals circumference equals 2 pi r. Therefore, circumference is 2 times 3.14 times the radius, which is 2 feet. Okay. And when you multiply 2 times 3.14, it's 6.28 times 2, and then feet. Right? So that's going to be 6.28 times 2, and we can do the math for that, but I think you know how to do it, and it's going to be circumference equals 6.28 times 2 is 12.56, 12.56 feet. Notice that we're not solving for area, so there is no squared. There's no squared up there. Don't do it. It's going to be wrong. Okay. Okay, this is going great so far. So that's example number 2, and all we have is one more example to try. So let's go ahead and do example number 3. All right, and I'm just going to go ahead and I'm going to find a circle for us to use real quick. Okay, this looks like a great one to use. Let's use, they're all fantastic. Let's just use this one. All right. So we have a circle there, and we're going to say that the diameter of the circle, the actual diameter, is going to be 4.25. What should we call that? 4.25, but that's more like, it's not feet, it's not meters. If anything, that's going to be 4 meters. So say 4.25 meters, even though it's off. So from here, passing through this gentleman who's in the center point, D, which is diameter, equals 4.25 meters. Okay, well, let's get to it. Circumference is equal to 2 pi r, which means 2 times, once again, 3.14 times r. So if you have 4.25, and you know what, let's make it, instead of 4.25, let's make this problem a little bit simpler for the sake of not having a really big problem right now. 4.2. So 4.2 meters. All right. Oh, that's not right. I almost made a big mistake, because 4.2 meters is the diameter, and we want the radius, don't we? So the radius of 4.2 is 2.1 meters. Now the first thing you're going to do is you're going to multiply 2 times 6.14, and you should have that memorized already. It's, 2 times 3.14 is going to be 6.28. Multiply that times 2.1 meters. Let's do the math for this. 6.28 times 2.1. Start with the 1. 8, 2, 6. Done. Placeholder. Now go with the 2. 2 times 8 is 16. Carry the 1. 4, then 5. And 6 times 2 is 12. That's a big one. 8, 8, 11, 3, 1, 1, 2, and 1. That's going to be 3. 1, 2, 3, stop. So we have 13.188 meters is the circumference. Okay, so as an added challenge, I think that we have enough time to talk about the formula for area of a circle as well. You're also going to need this for your IXL assignment. So let's go back for a little bit. Let's go back in time. And let's talk about not just the formula for the circumference. Now, let's look for the formula for the area. So the formula for the area of a circle is really simple. It's going to be, we're going to use A for area here. Area is equal to, try not to confuse the formula for circumference and area, but it's going to be pi times r to the second power. And the second power here applies specifically to what it's immediately next to, which is this r. So you're going to be raising whatever value r is to the second power. So let's go ahead and do the examples that we did here using the formula for area. Let's start with example 1 down here. Let's move this a little bit to the side. So here's the formula for area. Area is equal to pi times r to the second power. Remember, we're not writing a times there because we don't need to. And if you recall, in the example number 1, the diameter is 2, which means the radius is 1 meter. So let's go ahead and do that. It's going to be pi, which is approximately 3.14, times the radius 1 meter. 1 meter is raised to the second power, and the second power applies to what's in here. So it's going to be area is equal to 3.14. And then what happens when you raise in here, when you take 1 meter, so you take 1, what's 1 to the second power? What's 1 times 1? So 1 to the second power is 1, is 1 times 1, which is 1. So it's going to be 1 that's going to be down here. But it's going to be meters is also going to be raised to the second power. So what's meters times meters? Well, that's meters squared. It's going to be meters squared. Now you're going to multiply 3.14 times 1 meter squared, and that's going to give you 3.14 times 1 is 3.14, and then meter squared is just meter squared. That's your area. Area equals that. Okay, so let's not do all the problems, but let's do one more because this is interesting, and it's going to give you a feel for it. Let's do this one, the planet. So the radius is 2, so the area is pi times r to the second power, remember? So it's going to be area is pi, which is 3.14 approximately, times r, and the radius here in this funny example of the planet, remember it's 2 feet, 2 feet, and that's going to be multiplied to the second power. Okay, so 2 to the second power is 4 because 2 times 2 is 4. Let's do that first. And then feet to the second power is feet squared. And we're doing that first because you remember that PEMDAS, order of operations, you do parentheses first, then you do exponents. And there's an exponent here, and it's multiplying to what's inside the parentheses. That's why we're doing this first, order of operations. Okay, so 2 to the second power is 4. Feet times feet is feet squared. I didn't do that piece. Let's not make a mistake there. Okay. All right. Now you have 3.14, which is what the area is. Area equals 3.14 times 4. Okay, so all you have to do is multiply 3.14 times 4. I'll give you a moment for that in case you need to do it. you're going to get to, my calculations are correct, 12.56 feet to the second power. Okay, so you're getting 3.14 times 4, which equals this, and feet to the second power times 3.14 as well, that's going to be just feet squared. So your answer is 12 and 56 hundredths, or 12.56 square feet. Okay, I think you have what you need. You can go back and look at these notes. You can make tweaks to your own notes. I hope you enjoyed this video. And of course, I have not forgotten about your IXL assignment. For your IXL assignment, you're going to do the following. It's going to be EE 19.19. And you're going to be looking at the radius, the diameter. You're going to be looking for circumference, which we learned how to solve for circumference in the beginning. And the last thing we ended with was area, of course, of a circle. All right. Good luck, everybody, and good logic.